do a problem in this class using two different approaches. So it's the same problem, and in the first approach we're going to use the graphical approach, and in the second we're going to use the equations. And of course, when I say the graphical approach, we actually do use one of the equations. It's just not one that we use one equation that we actually use in the equations approach. But anyway, the equation is v equals at plus v naught. Because with the graphical approach, what we do is we actually plot this. And then, of course, this is v versus t. And then we get the area under that curve, like so. And this tells us the displacement, delta x, this whole area here. So that's sort of what happens. So let's go ahead, jump in and do this problem. So for part one, and I'm going to do this a little quickly because you've had some exposure to this, so I'm expecting that you're pretty good at it by now. So again, we have here 0, which is v naught, 60 is v final, and we're doing this in 7 seconds. So first, what I'm going to do is draw a little picture here. So we start at x naught equals 0, v naught equals 0, x final equals unknown, v final is 60 miles an hour, but we need to convert that into meters per second. So we have 1 mile with 1610 meters and 1 hour with 3600 seconds. So that's how we're doing the bubble method. And of course, when we do this, this will in fact give us 26.8 meters per second. Sorry, that should be 2 zeros there. It's good, so we go ahead and get that. And kind of continuing on then, we can actually then use the, zoom out a little bit here, we can then use the this result to tell us a couple things. So what I want to do now is actually plot what's going on here. So, and this is actually meters per second squared. Great. So now we have part one. We want to get the car's acceleration. So we use v equals at plus v naught. And we have 26.8 equals a times 7 plus 0. And so then when we do all this math, we end up getting that a equals 3.83 meters per second squared. I think we've actually done this one before in class, so this is a good little review for you. And we've got this as the velocity. Now what we want to do is plot the velocity versus time, and we'll do this kind of qualitatively here. I know some of you actually use the graph paper, and that's awesome, but I'll just do it here. So v versus time. Now we know that we reached this level of 26.8 at the top of the triangle. And when does this happen? This happens at t equals 7 seconds. So for part two, if we wanted to actually get the displacement, that's the area under this triangle. And that ends up being the area equals 1/2 base times height, which ends up being 1/2 times 7 times the height, which is 26.8. So we go ahead and calculate that, and we get 93.8 meters. And I'm actually going to go ahead and skip the graphing part here, because I've done it a lot. So that's the graphical approach. Now let's look at this problem again using the equations approach. And we've already got some conversions here, so we know that this is 26.8 meters per second. This is 7 seconds. And we can go ahead and solve. Now, if we want to get the car's acceleration, we can use v equals at plus v naught as we did before. So from before, we know that this is going to be 3.83 meters per second squared. Now for part two, using the same diagram, what we're going to do is we're going to plug any numbers into the equation. So x equals 1/2 at squared plus v naught t plus x naught. Okay. So one equation we could use. So we get x equals 1/2 times 3.83 times t squared, which is 7 squared, plus 0 plus 0. And when we do that, we actually end up getting about 93.8 meters. This is not the only way we could do this. We could actually use another equation. We could use v squared equals v naught squared plus 2a delta x. And then when we rearrange that, we'll end up getting 26.8 squared equals 0 squared plus 2 times 3.83 times delta x. And when we get delta x, that will also be 93.8 meters. So that's our basic approach to doing the problems. Two approaches. We've got graphical, and we've got the equation. So you should be fluent at both. Now, today we actually started this thing with free fall, And what I wanted to do was just kind of do this problem here as an example to kind of review where we're at. So we have a wrench striking the ground with a speed of 24 meters per second. So we start at a height, but this is V final. And let's be clear, V naught will be 0. The height is unknown, and height is actually x initial, and that's 0. We don't know how long it was falling for. And we know the acceleration is g, which is 9.8 meters per second squared. Let's draw a picture. So here's our wrench. Looks really stupid. And then here's another attempt to draw a wrench here. I don't know, it looks like I'm diagramming sentences. Anyway, the stupid thing falls, okay? So, and that's supposed to be falling. And then what happens is it hits the ground. So we have V equals 24 meters per second. We have x naught equals 0, V naught equals 0. And we have x final is unknown. And we have A equal, well, G is 9.8 meters per second squared. And we don't know the time. So it says from what height was it dropped? Well, here's the deal. When I look at my equations, I have V equals GT plus V naught. X equals 1/2 AT squared, GT squared plus V naught T plus X naught. And I have V squared equals V naught squared plus 2G delta X. These two equations, here and here, have time. But in the problem, I don't have time. So to get A, I'm actually going to use this equation right here. So I have 24 meters per second squared equals 0 squared plus 2 times 9.8 times delta x. So when I go ahead and calculate that, I get delta x is 29.36 meters. Excellent. Now for part B, what I'm going to do is I'm going to go ahead. It says how long was it falling for? Let's go ahead and calculate that. So that's going to be for part B. Might have got interrupted there. So for part B, we're going to do the same thing. So it says how long is it falling for? So we have V equals AT plus V naught. So we have 24 equals 9.8 times T plus 0. And we're going to go ahead and what we'll get for the time then, it's going to be around a little bit over 2.4. So we'll go ahead and calculate that, and we'll get 2.45 meters per second. Right. So that's pretty much it for the problems. Things should be pretty good, hopefully straightforward and simple. And this is it for problems. We're going to spend next week reviewing, getting ready, and then 2 weeks from tomorrow, which is Friday, Thursday, we're going to have an exam in 2 weeks. That's how I want to say it. So about 14 days from this date and today's date. So around October 10th, 11th, 12th, around then is when we'll have your exam. So that should be it.